Okay, so we continue with the lecture on what is data science. And after talking a little bit about this history of data collection and data analysis, we are now going into talking about this new discipline, right? The emergence and the evolution of data science. So uh, at, at some point, statisticians had to join computer scientists, right? Because discussing this topic, and actually I'm going to use something that computer scientists use, I think, garbage in, garbage out, right? So it's not about the machine learning. It's not about the algorithm, although it is very important to know what algorithms to use in what context. But it's also very important to, first of all, work with quality data, right? And this is something that statisticians know a lot about: how to clean the data, how to prepare the data for the analysis, how to look for outliers, how to make sure that the data is correct, that there are no observations that are repeated if that's not the case, right? To make sure there is the quality of the data is great. I remember when I first started learning about conducting survey and survey analysis, I was told that after a survey is conducted, there was double data entry, for example. That's one of the ways to ensure data quality. Two different people or entities or organization are asked to enter the same data, the data from the survey that is collected. And this kind of method is used throughout the institutions that conduct surveys, so that with this double, it's called double entry. So with this double entry, you make sure that, and then you compare, right, the one institution or one person's data entry to the other one, and compare those two different data sets and make sure that they match, and troubleshoot all the problems that exist in the data. So statisticians have done this for a really long time. And this kind of rigor was needed to conduct better computational analysis of big data, which, that became evident in the 1990s. So in 1997, Jeff Wu's lecture on the same topic highlighted recent trends in statistics, such as the growing use of computational algorithms and models. And so, it has been kind of this dilemma. Is data science now the new statistics? But I think, statistics and statistical theory are always going to be they remain its own field, again, because of this history I just showed you, and because there is a lot that this new field, data science, can learn and borrow and incorporate from statistical analysis. So there is statistical modeling, and the two cultures of, this is Bremen's paper, discuss the two approaches towards data analysis: a statistical approach of explaining the data, and a computational approach or machine learning to accurately predict future value. So this is, as you can see here, some of you may recognize this, this is kind of the clustering that happens with some of this kind of machine learning algorithmic create algorithmic outputs. And so I think it is very important to have these two approaches, right? So you cannot just produce patterns. You need to be able to interpret them. You need to be able to understand what those patterns say about reality. And so, because many times the computer may produce something that doesn't make any sense. I've taught statistical analysis for undergraduate students, for graduate students, for PhD students, for master students, for honors college. And so it is very important. And I always tell my students, you can't just use statistical software, whatever it is, R, Python, I use SAS. You can't just use a software to resolve a problem, whatever the problem is. You need to be able to know what statistical software to use or how to use it or what kind of algorithm to use in order to produce specific output. But that knowledge cannot be replaced by machine learning. So, the exponential growth of online activity, retail, social media, entertainment, banking, education, etc., that indeed necessitates a new set of skills for a data scientist. And this is something I really wanted to show you guys and to talk a little bit about it. Because there are a lot of misconceptions. Some people think, oh, it's all that takes is computer science. No, that's not true. There are new realities. There is new, definitely use of new computational methods, which computer scientists are better at. But you need a lot more than that. So I'm just going to start here and talk for a few minutes about domain expertise. Let's say, again, you work for a company. Some of you may go into the field of being a data analyst or data scientist, right? So let's say you go and maybe you work for health insurance company. Well, you need to know the domain you're working within. Is it medical insurance? Or maybe you're going to be working in an educational department, or maybe you're going to be working in a financial industry somewhere. You need to know a lot about the domain that you're working within, because only then you can actually make sense of the data analysis. If you don't know, um, the important aspects and concepts in the domain that you're working, or how people behave, if, let's say, if you're in education, if you don't know anything about how teachers collect exams, or how they perform tests, or what environment the students are they learning at home, are they learning in school, etc., etc. There are so many different characteristics of a social domain, right? If you have no expert knowledge in that domain, you probably will not be successful on that job. The other part is data ethics and regulations, right? In any industry, in any institutions, there are specific ethical rules that need to be followed. And, there are federal regulations against discrimination, for example. And again, a data scientist needs to be aware of that. We'll talk more about this later. Uh, there is an excellent book by, I'm just looking at it because I think it's right here on my table. An excellent book by Kathy O'Neill. We'll listen to one of her interviews. It's called Weapons of Math Distraction. She explains there how many of the algorithms that were used kind of built on already existing discriminatory practices. So for example, let's say a company wants to hire people who are going to be successful in that company, right? And so they are building this algorithm which looks at previous experiences of successful people, or at previous, how the successful people, who are they in the company? And then if in this company, the previous successful people were all white male, well, that sets the algorithm straight on a discriminatory path. And so there is a lot, again, to consider in this kind of context. The other part is data wrangling and databases, and this is certainly very important to know how to address these kinds of various databases and how to integrate the data from different databases. Or we'll also learn in the class that now you can actually conduct analysis in the cloud. You don't even have to download data, or you don't have to even have any of that data on your own computer, which again used to be the case. You can just conduct it in the cloud. So there is a lot of new information and new material to consider here as well. The computer science certainly plays a major role. Computer science and a high performance computing, right? This is acronym HPC. It's high performance computing. This is something that a data scientist hopefully will be aware of and has a background in that context. And these computer science skills are required to be able to understand and develop the machine learning models and integrate them into the production and analytic or back-end applications in the organization. Sometimes a data scientist may be asked or might be asked to develop an in-house applications, to perform a specific task. So it is a lot of different aspects of this profession that people have to be able to master. It's not easy. Sometimes people think, oh, you just need to know machine learning. Nope, nope, nope. And 100 times no. It's not all about machine learning. It's a lot about very many different aspects of this position. And that's why I am showing you this, because machine learning is only one of these aspects. Ideally, the data scientist needs to know the new methods of data visualization, particularly, as I mentioned, the reduction in dimensions, because sometimes you can have 11, 13, 20 dimensions that you cannot present if you don't use some of these more sophisticated methods of reducing those data dimensions. And statistics and probability, I think that a data scientist cannot perform their job well if they are not familiar with statistical theory and how data can be generalized. It's very important to understand those concepts, because they are in the basis of these kind of neural networks. That's the most common among the machine learning algorithms. And there are others, again, we'll talk more about later. But again, statistical theory, statistical analysis is in the base. It's the foundation of how we perform, how we derive patterns from the data. And finally, of course, this kind of analysis, if you find those patterns in the data and you are confident, or the data scientist is confident that these patterns are indeed strong and relevant, and these patterns have been derived from a good, clean data set, then these patterns need to be communicated within the organization that the data scientists work with. You can't just send people outcomes or graphs and say, here, look at that. Nobody would ever understand that. And people need to be able, data scientists need to be able to communicate clearly the results from such exercises. So this is, an important, in my opinion, presentation of what a data scientist needs to have as a skill set. It may look a little daunting, but I think that is perfectly possible. And there are a lot of different domains, right? Different social domains, different areas, industries where such skills now are very looked for, very sought after. And it is important, even just for our own, even if you don't necessarily want to pursue that as a profession, I think it's very important to understand how this machine learning, how the algorithm, how are they related to data quality, to methodology, and to kind of make the link between good strong methodology and outcome. So just a word on applications quite quickly, because I think our time is, we have only 10 minutes left. So where is data science used? Well, data science is used everywhere, pretty much, right? Um, if we know that it's used in sales and marketing, again, I just have posted here on the slide a few examples. Walmart has been using data science to introduce new products based on social media trends, credit card activities, etc. An increase of 10 to 15% sales for 1 year. It was reported that Walmart had because of the use of data analytics. And certainly, again, as much as we don't want to think about it, they are using our credit card activities, they are using our presence online to make these predictions and to know what kind of products the consumers would want to have, and kind of try to provide those products. The government certainly is using data science in major ways. Certainly in health, there are a lot of initiatives that are spearheaded by the government in the health, specifically, again, in precision medicine. We'll discuss that a little later in the class. The police are using these predictive algorithms. Certainly, they have been using profiling for a really long time. So for them, this was a no-brainer to use data analytics in these new ways. And certainly smart cities, or now everything is smart, just like we have precision everything, we have everything that is also called smart, smartphones, smart refrigerators, smart TVs, and smart cities. And that's something that we also discuss later in the class. In sports, that's one of my favorite baseball players. But I wanted to say something. I would encourage you to watch this movie, Moneyball. It was produced in 2018. Brad Pitt stars in it. I think Jonah Hill also has an important role, and it does showcase this movie how data science was used to recruit players. And so this guy, this coach that Brad Pitt portrays in the movie, discovered, based on a college student graduate that had the economics major in college, that on-base percentage and slugging percentage were more useful than batting average. And so he used this kind of very new tactic to recruit baseball players. It's very interesting, particularly if you like baseball. I think you will enjoy the movie. And of course, it's data analytics are used in finance and in the stock market. Specifically, a recent MIT study combined the use of alternative data with traditional data, such as financial records, and the results showed that with the right data, computers outperform humans by 57%. So that is something we will also get to talk a little bit about later in the class. Okay, so I have one more slide, but I'm going to stop sharing. I think I'm going to finish this presentation on Monday. There is only one more slide left.